Hello everyone, it's Sam. So today we talk about introduction to function like the old time. So we started warm up right here. Can I go back a little bit? Wait. We'll start with warm up, and then when they go to a lesson called repeating output. So now let's get in warm up. If I click this button, there. Okay. Now have the inputs of 2 a.m., 7 a.m., and 9 p.m. And the input 2 a.m. goes to output 7 a.m. Input 7 a.m. goes to output 12 p.m. And the input 9 p.m. goes to output of 2 a.m. So what was the function? So I see here 2 to 7, and it's both a.m. So it's like adding 7 to 12, but it's p.m. But it's just like a.m. 12 p.m. is like the afternoon. It's like lunchtime. And 9 p.m. to 2 a.m. We know that. So it's like 5 hours later. Yeah, am I correct? Next, I already have a function and we need to find the output. So I have an input of 6 p.m. and the function is 5 hours later. So what will be, the output? So it's like plusing 5, right? So 6 plus 5, I think it's equal to 11. So it's 11 p.m. Next, we're going to find output to the input. So it's actually the input to the output, but now we do output to input, so we need to do opposite way. Instead of adding 5, we're going to subtract 5. 3 minus 5, maybe say that's negative 2. If negative 2, but there's 12 p.m. as well, So, and then 12 p.m. go to 11 a.m. and then 10 a.m. So, wait, no, it's 10 p.m. Oh, I misclicked. So we done a warm up. Now, it's time to do the lesson. Oh no. Now, let's get in. So laggy. Here.
Now, let's look at functions
where different inputs can give the same output. Which rule could produce these outputs?
So this is true and false. So that's not that hard. I'm gonna chat with him. So see, I can chat like old time now. So let's see. Oh, so 6 and 9 is true, and 13 and 14 is false. So I see that as like division or multiplication, right? I know it's true and false, so let's know that.
Good thinking. Let's test it. Inputs 6 and 9 both map to true. What do they have in common that 13 and 14 don't?
So 6 and 9, I think, is not even. Not 6 is even, but 9 is not. It's greater than 5, correct? But if you say greater than 5, in the input 13, 14 is also greater than 5, but it's not a correct answer, it's false. So we count that. Less than 8, 9 is more than 8. So it's only last answer is division by 3. 69 can division by 3, but divided by 3, and 13 and 14 can't. That must be the correct answer.
Well done. Now find a specific output. What is the output when the input is 23?
So it's can't divide by 3. 23 can't divide by 3, so it must be false. Bingo! Next.
This time went backward.
So now it's true. Now it's true. So something must be divided by 3. Can 28 divide by 3? No. It's going to divide by 7. Can 30 divide by 3? Correct. But let's continue. 29 can't divide by 3 and 31. So 30 is the correct answer.
That's right. So here's the idea. Multiple different inputs can produce the same outputs. Do you see how that works?
Yeah.
Now the outputs are numbers instead of true and false.
So 12 equals 0, 16 also equals 0. And then 17 equal 1, but 18 equal 2. So that's also seem like something. What do you seem like? So first I have subtract 12. So why would subtract 12 on 12 be 0? That's correct. But what about 16? 16 will equal to 4. So I don't think of that. Divide by 6. It's also not that, because 12 divided by 6 you get 2. 16 maybe can't. Remainder after division by 3. So have remainder after division by 3. But 18 also have remainder. Let me see. If divided by 3, you have 6, right? So it is have a remainder. 12 also have remainder. Remainder after division by 4. So maybe I'm doing something wrong. So this will be equal to, wait. Oh yeah, because inputs division by 12 divided by 4 don't have a remainder. 16 also. But 17, 18 does have a remainder. It's 1 and 2.
Nailed it. Apply this new rule to a specific input.
So 23, if divided by 4, is less than 3. Because 20 can divide by 4 and I get for none. So 23 must missing 3, I guess.
Okay. Last problem. Which input would produce an output?
So it must be something like 21. I just say 20 can divide by can divide by 4 without giving any remainder. So 21 must be answer.
So here's the big picture. Sometimes different numeric inputs produce the same output. Do you see how that works?
Yep. Oh no, put a question on it.
Look at inputs 12 and 16. Where do their flow lines go?
0. I see button and click button.
Yes, both land on output 0. So what does that tell you about how functions work?
Let's make
Can you
left.
say it in your own words? Can two different inputs give the same output?
Yes.
Exactly. Different inputs can share the same output. That's a key idea. Ready to try the next problem?
Okay, I'm going. B.
Last step. Let's check your understanding.
Yeah. 3 times 0. 7 times 10. What? 13 times 2 and 16. First I have to subtract by 3. 3 subtract 3 equals 0. Yeah. But 7 subtract by 3 does not equal 4. So let's go to the next one. Add 7. It's always wrong because 3 plus 7 equals 0. That's absolutely wrong. And round to nearest 10. 3 round to 0, correct. 7 round to 10, correct. 13 round to 10, correct. 16 round to 20, correct. Okay, round to nearest to 10. 24 round to what number? So I think it's round to 20 because, this is like super simple. We don't need to check any answer. Round to nearest 10, but round to 0 means must be a number that's very close to 0. Negative 11 can't, 6 can't, 11 can't, so it must be negative 4. This is the end of my lesson. I hope you enjoy. Bye. See you next time.